Right. So I give another example. Move there. Right. Right. Anybody do it? What's going on? And that's a sensitive one. Do what? Huh? What? Huh? Do differentiation? No, nobody do it. Nobody do no regression. Wasn't there any group? Let me check the status. Thanks, the password for that. Oh, yes. Yeah. Right, try this one here. Try this one. Might as well. If you had to do it, you'd have know that 90% of it you did already. Yeah. In class. And yeah, like 3 million. Right. Try this one. Try this one. Try this to the power 3. Try that quick. Try that quicker. And then we start down after the key comes there. Where's not this sign as we're supposed to do it? What the differential assign X? Us. Not a substitute of us. Hurry up and get this one. Hurry up and get the question. Oh, shucks. All right. I need spot the body can see on the thing. All right. Next time. I'll get it. I don't know what the right on the So let's look now, boss one. I get nobody somebody asked me to send something online, but I didn't check it yet. Oh, the money thing I read so far. Yeah, send it now. You can send it on WhatsApp, you can send it on email, send it somewhere. Well, somebody want an email. Organizing marks. Organizing what? Hurry up, are you done? The title and introduction. Title and introduction. Done what? Right? Use somebody in the C rules there. Use somebody in the C rules. Use some of the NDC rules. Oh, you remember the NDC rules? Look at the NDC rules. Look at your book. I can't teach you all if you don't know how to do certain things. There's 3 there, yeah? This was V2. This was V2. Sorry. This was V2. This was V2. If you put 3, that's okay. That'd be a little off. Right? So how again? What's the first thing I have to do here? What's the first thing? Get rid of what? The cube root, right? So how are you doing that? 3 by what? 3 on? No, what? When we have this alone, Yeah, I went through this earlier, you know. If we have this alone, huh? What's this? If I'm moving this, where will be? A half. Yeah? So if I have, what this will be? What? 3 bar. What? Oh, right? It's just this. Yeah? 2. Yeah? So what you say now? What you say? Right? We're replacing the root with 1/3, yeah? You all remember this rule in indices. What is happening here? So you get what? Yeah? You could use that rule here. Yeah? Right? And differentiate. And differentiate. And differentiate. Hey, this time take it down. Take down this. Yeah, last time I just showed it. Take it down. Take it down. Take it down quick. I can erase it now. No. Yeah, right. It's a phase when we that you observe or you observe the observation. You see, so you have to wait until the you. And as a pronoun there, crazy to the condition. Huh? You pronouns it. Yes. Well, yeah, it's now like the way. Wait, maybe it looks like you see it visually. You see the problem, right? So then, yeah, you see the question. I got a jump on. Absolutely. I see the box. Yeah, it's fine. Yeah. Yeah, it's but you see how it's going to use the point, but you have to use that because we have a party, right? And you know, uh, the people are not everyone moving. So come up with a scenario that was suitable. Yeah. Come up with a scenario. You need a scenario to be sure that it's correct. You need to work on. I mean, this will be then you can don't look at the box this part. The next part of the example connect the needs. Take on here is something out there. But it's fun, you want to be off. Yeah, it's not good. That's good. That's great stuff. That's what somebody that you wrap. Like ten, four, eight, different. Oh, there's no notes. Right, so let's finish up. This one talking about the more slowly. Go slower. Which one is this? Slower, yeah. Pay attention to the English, can you share? More slowly, but more slowly is not something about him. Right. What it is here, right? Let's get this in a way we can differentiate it, right? So we multiplying it. 2 by 1 third is what? 2 thirds. Good job. Good job. We done with the fraction multiplication there. Right? And then what rule we using here to differentiate? The shortcut rule, right? You could use the chain rule, but that's real rule. So what we doing here? Somebody help me. So bring down 2 thirds. Good job. Differentiate, huh? No, you differentiate inside of here. So it will be what? 2. And then what we have here now? 2x minus 1. Okay? So have dy dx. I just multiplying these two brackets, yeah? So we will get what? 4/3 by 2x plus 3 by what is negative 1 2 again. But look how they gave us it. We need to give them it back in the same form, right? So how are we making this positive? Carrying it below. So we have 4/3 by 2x plus 3 to the power of 1 2. Yeah? Right? And then, but we need it back into the cube root form, right? So we have 4/3 2x plus 3, and don't forget to put the 3 outside here. Yeah? And that is your dy dx. Yeah, that is your dy dx. Huh? This is a 3 and this is a 3. This 3 from here. There's the 3 from here. Yeah? This is the 3 from here. And yeah, is what? It's a cube root. Yeah? Not square root, is a cube root. Yeah? Right, let me know when I can use. Let me know when I can use. Yes. Yeah. No, yeah, that's not that nice, but in France, see. Yeah. No, you gotta put your route in for about the way up. Have you guys would not, then you would not. So, it's common over some sign. Yeah. Yeah. Well, yeah, it's sure at the beginning. Right, I could do this. I could, right, so let's do the applications of differentiation. What dy dx gives you? What dy dx gives you? Yeah, what is dy? I keep mentioning it. Dy dx is what? The gradient, right? So just remember that, right? Our d, oh no, I hear wrong one. Right? So dy dx is our gradient function. Yeah. So when we find dy dx, right? We find in an equation that we can get our gradient. Yes, if I have this, let's say I have this here. 6x, I'm gonna give you all something easy to do. 2x squared plus 4. Yeah? Right? If we go right, actually. Watch here, right? Right? dy dx, yeah, is 4. I just doing it quick, right? 4x, yeah? What do you do long? Yes. Bring down the 2. We have 2x, 2 minus 1. Yeah? So we end up with 4x dy. So this is our gradient function, yeah? To get a gradient, they would give you a value for x, yeah? Let's say they would say x is equal to 1, yeah? When we substitute 1 into this, right? This would have been our gradient. This would be our gradient. Yeah? You all good with that? Right, take down this. Take it out. Shots. Yeah, that's not nice. Huh? They'll give you X. They'll give you X. I'll check it out though. But yeah, check it out. Yeah, but I think that what I do think it. Yeah, boss some money. If you do have a subject that isn't that subject class. Still for my guy, too. That's what. Yeah, but still. Focus on family. If you focus on two things, you'll get lost. Right, so here's what we need to be able to do. Right? We have to be able to do something. Well, I call it double differentiate, right? So when we find dy dx, yeah, right, we have to find d2 dy dx squared, yeah. So this is called the first differential. I think that's what it's called. And this is called what? What do you think this is called? Second way, yeah, right? Yes, that is right. Second. Yeah. So what we doing, right? So let me give you an example. Let me start off here. Y is equal to what number? Like 4x squared plus 2x. Yeah? If we differentiate this the first time, yeah, see what I'll get here. 4 squared plus 2. Yeah, so you bring down the power. You have 4x, 2 minus 1. Plus, and this will become what? 2. So dy dx is 8x, 2 minus 1 is 1 plus 2. Yeah? What d2 dy dx is, we just differentiate in this again. Yeah, if I differentiate in 8x, what I'll get? 8. And if I differentiate in 2, what I'll get? 0. So d2 dy dx squared is 8. Yeah, and this is the second differential, right? Here's another way they could write it. Yeah, here's another. You remember functions? Yeah. So normally we would say f of x is equal to some equation, right? Let me just use the same one. 4x squared plus 2x, yeah? They'll say this, yeah? To show you differentiation, they'll do this. F of 1. Yeah? This is the first differential. Yeah? And then they'll do f of, this is the second differential. Yeah? So they could write it either way. They could write it like this, or they could write it like this. Yeah? Just put it in here, right? F of 1, f of 2. Yeah? Right, just take that out. Hey, practice, so don't take this one, please. You're good? No? Yeah? Well, I checking
Oh, you check it, see.
What do you want me? Difffer. Good. Right. Sure. Difffer. Where I get I from, what? Where I get I from? Right, sorry. Right, it's one word, eh? Finished? Not really. Could I erase this gradient function? I can erase the gradient function. Gradient function. We are living with one foot. Huh? So living with forget to listen with foot updates.
Varma. Así la pongo aquí.
Yeah, right? Double differentiate this. Double differentiate this. So y is equal to double differentiate this. Well, double differentiate. Hurry up and double differentiate there. Hurry up and double differentiate there. 2 minutes, 2 minutes and I'll finish in that. Yeah, you can keep differentiating. I don't know. Finish. Differentiate again. Yeah, that's something that differentiate again. But differentiate this one again. I'm doing what? I'm bringing down the 3. 3 minus 1. Plus what I'm doing here? Bringing down the 2. 2 minus 1. Yeah. This is going to become what? 4 and what into the 2? 0, yeah? So we have dy dx is equal to 80 x squared plus 4x plus 4. We good there? Everybody good? Start here. Right? Now we have d2 dy dx squared, yeah? What do we know? Amani. Is that one whatever we can do? And then what happens is 0, yeah? So then you end up with 36x plus 4 is d2 dy dx squared. Yeah? Are you good with that? Yeah. No, four is only 4 doing class to doing reality. Can you raise here? Yeah? Same person teaching back. Who teaching back now? No, the last week. Who teaching last week? What about teaching last week? Let's continue. Continue. This is wrong. Yeah, I'll do labs also. Okay, you read this one? Yeah. Right. We in quadratics, right? Remember, we learned 2 types of curves. Yeah, what was the shape of the yeah, what was the maximum shape? See? No, what was the shape?
1.0 comma. Oh,
Yeah. Wait this.
okay.
Okay, let's have the minimum.
The number one.
This is a
Then
U. Right, so this is a minimum. And this is a maximum. Right? Right? So here's what we're going to learn, right? If d2 dy dx squared is more than 0, then the curve is a minimum. Yeah? If it's more than 0, it is a minimum. Yeah? And if d2 dy dx squared is less than 0, what do you think it is? Maximum. Yeah? Right, now let's get one to show you. Let's get one to show you. It's simple, right? They did double differentiate and they substitute in a value.
you can work out.
Work out.
Yeah.
No, yeah, substitute the value. I'll show you one. We got past paper one time. Right, as well as the past paper ones. Right, take this down by time, because I need a little more school fun going. Right, so this is the second application, right? The first application was the gradient function, and now this is the second application. Right, this is to find the nature of the curve. You guys are right in this question, right? They rather work it.
Yeah, that's right. You'll give it a
Come on, you finish right. Come on, you finish right.
What question is this? Right?
2010. There's 2010. Sorry, it's bad month is only
Major.
huh? It's only
Oh, that's really sensible.
they don't have any odd months exam than that. Huh? Because slow too slow to do it, you know.
I feel like I must have done. I'm gonna remake this.
Yeah, sign up for now if you want to do it then job. Sign up.
From now?
Yeah, sign up.
Thank you.
One tell them in the office, I want to look at exams for odd months. No. Right, I finish right though. I'll finish.
Yeah.
Right? First thing here, right? So they said to find the stationary points, right? So that's the first thing we're going to do. To find your stationary points. Stationary points. We differentiate the equation they gave us. Yeah? Watch it now, watch it. I'll let you right after. Yeah? First thing we're going to do is differentiate this to get our stationary point. So if we differentiate and it's alright, and it's like in terms of the function now, yeah? Right? So we have already whole thing like that, alright. Watch it now, just watch it. I'll let you right after. I'll let you alright. Right? If I do, right? We bring down the 3 and we have 2x 3 minus 1. Right? Minus, bring down the 2. We have 9, 2 minus 1. Yeah? And then this will become what?
Plus 2.
Plus 12. Yeah? If we multiply here, 3 by 2 is squared. Squared. Yeah? Yeah? Minus 18x plus 12. Well, this is our first differential. Yeah? To find your stationary points, we have to solve this equation. Right? So you put this into a calculator and get your x values. What kind of equation this is? This is what? A quadratic, yeah? So get your values. Get your values there. So it's be some nice whole numbers. Hopefully. Once we differentiate, correct?
2 and 1.
2 and 1. 2 and 1. And this is our stationary points, right? What's the second part? They want us to distinguish their nature. So when they ask for their nature, they ask if there's a minimum or maximum. So what we have to do after? What we have to do? We have to double differentiate it, right? I'm just doing it on the side here, so it'll be in the camera, right? So we have double differentiate, right? If we double differentiate, we bring down the power. We have 6x squared minus, what is going to become? 18. And what happened to the 12? Oh, yeah. Yeah. And this will become 0. So if we double differentiate, this will end up with 12x minus 18. Yeah. Right. So now we have to figure out if it's more than 0 or less than 0. Yeah. So here's what we do it. We take in our stationary points and substitute it into here. Yeah, both points. Yeah. So first you do it, x is equal to 2. Yeah. So we put in f of second function 2. I put 12 multiplied by 2 minus 18. So we have 24 minus 18, which is 6. Is 6 more than 0 or less than 0? More than 0, right? So d2 dy dx squared is more than 0. So what we have there? A minimum, right? Now we have to do it for the other point. We have to do it for the other point. I'm just doing it here, right? And we're kind of disorganized, but I'm doing it. Yeah? Right? So now we have, right? F double of 1. Right? Right? And then we have, what is 12 by minus 18. So we get 12 minus 18, which is minus 6. So d2 dy dx squared is what? More than or less than? Less than 0. So it's a maximum. Yeah, it's straightforward, just like this. Yeah, you just find the stationary points, you found it, and you distinguish any nature. Yeah? I think you try one now. We're gonna try our next one. No, wait, not down.
We know third or something.
Right, so something. A point is have what? A point always have an x and y value. So we have to find the y value. See? Yeah? I'll show you. It's really easy. It's very easy. You're right up to here yet?
Yeah.
Yeah? No? That's our first second, right? How you think we're gonna find the y values if we have the x? Substitute it into which one? Yeah? Just substitute it. No, not this one. Yeah? Just substitute this into this. Yeah? Your first differential. Yeah?
I'm gonna get away.
Sorry, the first one. Yeah, yes. The first one. Okay, sorry. My bad. Yeah? You substitute it into here and you'll get your y values. Yeah? Substitute it from now. Just substitute it. And just always write a point. Always write a point. X and then y. X and then y. Yeah? Just find the y values there for me. Jalan sana no.
I will start out from the end.
Are you listening? Always find a y value.
Iba.
Yeah, no, I understand. Always find a y value. Yeah, see?
Substitute value says
Right into this equation. Yeah? So all you're doing is taking 2 and everywhere you see x, you put it in 2 and you'll get a value. And that's your y value. So we have x is equal to 2, and then we have f of 2, which is 2 by 3 cubed minus 9 by 2 squared plus 12 by 2. Yeah? And then we have x is equal to, oh, let's start with the value, right? Let's start with the value. X is 1, which is f, yeah. Well, I have 3, yeah, I have 3 with. There's a 2. Well, I was actually wrong. Right? And then we have f of 1. And we have 2 by 1 cubed minus 9 by 1 squared plus 12 by 1. Yeah, well, let's have 4. Right? So what's the coordinate for the first one? X is 2, y is what? 4. And then the second one is 5. I'll double check that. The little shape with it. Right? So x is 1, y is 5. Yeah? So when they ask for the points, the stationary points, you gotta put the x and y value for them. Yeah? You okay with that?